Hi guys, today's lesson is going to be on something called factorials. And factorials aren't super complicated, but they're really useful for things like counting, like our fundamental counting principle, and they're used in probability quite a bit. So all they are products, meaning multiplication, and they're indicated by an exclamation point. So this is an example of what a factorial would be. So in this example, we have 4 factorial, and I'll tell you how to calculate that in just a second. Make sure you get all of this in your notes, so if you need to, you can pause the video so you can record what you need to in your notes. Okay, so when we talk about factorials, it's read, that exclamation point, as read as the word factorial. So 4 factorial is said this way and written with 4 and an exclamation point. And what it means is 1 times 2 times 3 times 4. Basically, it's a product multiplication of that number and all the whole numbers below it, starting with 1. So the answer to 4 factorial is 24. All right. In general, this is just an very generic formula for n factorial. It means the product of all the whole numbers, integers, from 1 to n. So, in conclusion, n factorial is 1 times 2 times 3 times all the way up. The ... just means kind of etc. all the way up to whatever n is. Sometimes we see it written instead of 1 times 2 times 3 times 4. We'll see it starting with the 4 times 3 times 2 times 1. And a lot of times people will just kind of leave off this 1 because multiplying anything by 1 isn't necessary. So essentially, this answer is just 4 times 3, which is 12, times 2, that's where we're getting 24. So 4 factorial is 24. All right, so let's do some examples and look at why this is useful in a counting situation. So we've done some fundamental counting principle problems before. Here's an example where it might be useful to use the factorial symbol. So we have 8 songs to play at a dance. We have to choose what order to play them in. How many different arrangements of songs could we make using all 8 songs? So the fundamental counting principle is something we've talked about before, and anytime you're trying to arrange things in a particular order like this and count how many different ways you can do that, the counting principle works very well. So in this case, basically, the events that I have to choose, the decisions that have to be made, is basically starting with which song do I play first, which song do I play second, which song do I play third, all the way up to the last song. So 4th, 5th, 6th, 7th, 8th. So I have to pick which song goes in that first spot, which song goes in the second spot, and that's how I can count up all of those possible ways to arrange the songs. So when I'm doing my first song and I have to make my choice for which song to play first, I can choose from any of the 8 songs. Now, when I choose my second song, I'm not going to play the same song that I already played first. That's kind of an important part of this fundamental counting principle and using this factorial. I'm not going to put an 8 here because there's one song that's already been chosen for the first song, and I can't choose it again. This is kind of like when we did passwords where the numbers can't repeat. You're not going to have all 8 to pick from. Now for the second song, I only have 7 songs to pick from. So I can pick any of the songs except whatever one I played first. When you get to the third song that you're going to play, you only have 6 options because I can choose any of the songs except for whatever one I chose in the first or the second spot. And it keeps going down like that. By the time you pick your 4th song, you only have 5 options, 4, 3, 2, 1. And the fundamental counting principle says multiply these together. Well, we can see how if I'm going to go all the way down to 1, this is the same as 8 factorial, and it's a shorter way of writing it. In fact, a lot of calculators have this exclamation point as a button. Sometimes you have to press Shift or some other kind of second key first because it's written kind of above the buttons. But you can literally just type on a calculator. Most calculators, you can type 8 find that factorial button, and it'll automatically calculate 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 for you. On a calculator, if you don't have that button, though, you still have to manually type in 8 times 7 times 6 times 4 times 3 times 2 times 1. So if you want to, pause this video and maybe look to see if you have that exclamation point on your calculator. Also, sometimes if you don't see the exclamation point as a button, if you see something, a button that says something like PRB, or maybe even PROB, it's gonna that stands for probability. And if you click that button, you might then see on your calculator a couple of different options, and one of them might be this exclamation point, where you can select that. So it's very handy if you can figure out on your calculator how to get the factorial button, but it's not necessary. You can just simply type in 8 times 7 times 6 all the way down to 1. All right, so this actual answer, I'll get it in just a second here. Whoops, that is not what I wanted to do. This answer I just got on a calculator is 40,320. So there are 40,320 ways to arrange 8 songs. So anytime you're making an arrangement and you're actually going all the way down to 1, which means you're using all of your songs or whatever the object is, and just putting them in a different order and seeing how many ways you can order it, a factorial button will get that done for you. Okay, so here's another example, very similar. You have 10 books to arrange on a bookshelf. How many ways can you place all 10 books? That means which book goes in, the far left spot, which one goes in the middle spot, the far right spot. So you have 10 books to arrange on a bookshelf. This setup's going to look just like the one before. Using the fundamental counting principle, you have to pick which one goes in that first spot, maybe the far left spot if you're counting that as your first spot. Then you have to pick which one goes in your second spot, third, fourth, fifth, sixth. And we're using all 10, so we're going to go all the way to the 10th spot. And essentially, for my first option, I have 10 books, all 10 books to pick from. When I try to pick my second book in the second spot, I have 9 to pick from because I can't choose the same book for the first and the second spot. And then 8, 7, 6, 5, 4, 3, 2, 1. So this turns out to be the same thing as doing 10 factorial. You're multiplying 10 and all the whole numbers below 10 down to 1. So on a calculator, if you have a factorial button that you have found, use that. You can just type 10 factorial, or you can do 10 times 9 times 8 all the way down to 1. So you do that, and then I'll put the answer up here in a sec. All right, and I got a huge number, over 3 million. 3,628,800. So hopefully you got the same thing. That's 10 factorial. Okay, so aside from these arrangement problems, sometimes we're just asked to do some calculations with factorial symbols, similar to square roots or absolute value symbols. It's just another mathematical operation. So anytime you see that exclamation point, it's just an operation that you have to do. So, for example, if you had to do 6 factorial minus 5 factorial, what you would have to do is treat these, as far as order of operations goes, you need to do that first, because that's multiplication. So multiplication would come before subtraction. So you have to actually do 6 factorial. Either multiply it out like this, or if you have a factorial button on your calculator, do that. Once you get that, then you'll do the same with 5 factorial, and then you'll subtract them. So pause this video right now and do that mathematical operation and come back and check your work in a sec. So I got 720 for 6 factorial, and I got 120 for the 5 factorial. Then you subtract those two and you get 600, and that's your final answer is 600. You can see there's not really a shortcut for doing this. It's not like 6 factorial minus 5 factorial is just 6 or anything else. You have to actually multiply them out separately and then do the subtraction, just like any other PEMDAS or order of operations problems. Okay, here's another example with division. This one's kind of neat. If you don't have a factorial button for this and you tried to do 22 times 21 times 20, that would take a while. And then you'd have to do the 19 factorial separately, then divide. That's what this is saying to do. Find 22 factorial, find 19 factorial, and then divide them. Your calculator may or may not even allow you to put in that because this is such a huge number that you might not be able to do it even if you had the patience to put it in the calculator. It might be too big a number to display, basically, on the calculator. So I'm going to show you a shortcut for doing this using some rules that you probably already know. Move this over just a bit out the way. All right, so let's write this out at least partially. Actually, let's do a smaller example down here. With instead of 22, we'll use something that you could do on a calculator pretty easily. 6 factorial over 4 factorial, since it's easier to write it out. And then we'll come back to this 22 over 19. So 6 factorial, if we expand it, means 6 times 5 times 4 times 3 times 2 times 1. 4 factorial, and it would be handy if you would line them up, the 4s on top of the 4s, is 4 times 3 times 2 times 1. Using rules that we should already know from simplifying, say, exponential expressions or other fractions, I can basically divide the top and bottom. 1 is unnecessary, right? We don't have to multiply by 1. If I simplify this fraction by dividing the top and bottom by 2, I'm essentially just undoing this times 2. All right. If I divide the top and bottom by, say, 3 to simplify it, I'm essentially just canceling out this 3 and this 3. So anytime you have the same number or letter, if you've experienced that before, on the top and the bottom, they cancel out. They're not going away, they're turning into 1s, but anything times 1 you don't have to write. So I can cancel out the 1s, the 2s, the 3s, and these 4s, and what I'm left with is 6 times 5 on the top. I do have something on the bottom, it's 1. All of these kind of turn into 1s because you're dividing something by itself. And this is not very difficult to do. You don't need a calculator and doing all that multiplication. It's shortened the process for you. 6 times 5 is 30 over 1. So the answer to 6 factorial over 4 factorial is just 30. Let's use that same principle with 22 over 19. So we're going to start writing it out. You can write out all 22 on the top if you'd like, but I'm going to do 22 times 21. We need to do a bunch of them, 19, 18, 17, and then I'm just going to kind of go dot, dot, dot down to 2 times 1. So the dot, dot, dot just kind of means etc. Y'all see the pattern, 16, 15, 14, all the way down. 19 factorial, I'm going to do also, but I'm going to line up so that it's easy to cancel. 18, 17, etc., all the way down to 2 times 1. Now we can use that same principle. The 1s cancel out with the 1s, the 2s with the 2s, all these numbers between 17 and 2. In fact, everything from 19 on down cancels out because both the top and the bottom share those same factors, 19, 18, 17, all the way down to 1, so they can cancel out on the top and the bottom. And what I'm left with is, on the top, I have 22 times 21 times 20. On the bottom, I have 1. So now your calculator can handle this for sure. You can multiply 22 times 21 times 20. So do that right now. And I got 9,240. Hopefully you got that too. So that is the answer to 22 factorial divided by 19 factorial. Okay, so what I want you to do next is try this last problem on your own. Pause the video and try to do 106 factorial divided by 104 factorial, and try to do it using the canceling method because your calculator won't be able to actually multiply 106 factorial. So pause now and come back as soon as you have your answer. Okay, so essentially everything from 104 down on the top and the bottom cancel, 104, 103, 102, all the way down to 1, and the only thing that you have left is 106 times 105 on the top which is 11,130.